So here for this problem, we do have a nonlinear systems of equations, and both equations are equal to y. So what I'm going to do here is set them equal to each other. So that means we have x squared minus 2 equals x plus 4. The next step I'm going to take is to move all the terms to one side, so that way the equation will equal 0. So we're going to subtract x from the right and from the left, and we're going to subtract 4 from the right and from the left as well. And you can see here that the right side does equal 0. Okay, so we have x squared minus x minus 6 equals 0. Now, this is a quadratic equation, so I will factor. So I'm looking for two numbers that multiply to -6 and add to -1. Those numbers are -3 and +2. So I factor x minus 3. So I'll do that. X minus 3 times x plus 2 equals 0. And then I solve each factor. So of course we have x minus 3 equals 0. And so we know that x equals 3, solving for x. And then for x plus 2 equals 0, we solve for x, and x equals -2. Okay, so these are the x values where the graphs intersect, right? So what I'm going to do here is look for the y values, and that means I can substitute each x value into one of the original equations. So I'm going to choose the second equation, y equals x plus 4, and where we see this x, we're just going to plug in x equals 3. Let's go ahead and do that. We have y equals, and then x is 3 plus 4. Y equals 7. So the first point is 3, 7. So we have 3 and 7 here. And then for x equals -2, we're going to substitute that into the original equation, y equals x plus 4. So we have x here, we're just going to place that with a -2. So that is y equals, and that is -2 plus 4. That means y equals 2. Okay, so our point is -2, +2. All right. So the points of intersection are, as you can see here, 3, 7 and -2, 2. And each ordered pair represents a point where the line and the parabola cross. So you can see that here on this graph, right? So when I graph both equations in decimals, I can clearly see the parabola and the line crossing at the points 3, 7 and -2, 2. So that confirms the solutions we found algebraically. So we see the points here, here, and we see the parabola crossing through those 2 points on the line. All right, so in the next problem, we're going to look at a complex numbers problem, which will be the last problem in this series. All right.